let's get started on Chapter 1, Introduction to Computer Networks. In this section, we will discuss the components of a personal computer, the components of a local area network, advantages of networking, peer-to-peer and server-based networks, types of servers, LANs and WANs, packets, and binary math. So let's turn to page 2, Overview of Computer Concepts, and in this section we are going to discuss the components of a personal computer. And you might ask, if this is a networking class, then why are we discussing the components of a personal computer? And the answer, and this is because a network is composed of interconnected computers. So if there's something wrong with the network, there's a possibility that there is something wrong with one of the computers on the network. So let's turn to page 3, the components of a personal computer. A personal computer is made up of input hardware, processing hardware, storage hardware, and output hardware. For example, a user types 2 plus 2, 2 plus 2 is the data, into the input device, which is the keyboard, and presses the enter key. The 2 plus 2 gets added up. It gets processed by the processing hardware in the system unit. And then the data can be output to the monitor, which is output hardware, or the data can be output to the printer, which is output hardware, or the data can be stored to the hard disk, which is storage hardware. Let's look at the processing hardware. The processing hardware, which is called the system unit. It's also just called the box. And if we look at the inside of the system unit, we will see the power supply, the hard disk, the DVD drive, and the motherboard. So let's pull out the motherboard and take a closer look at it. Page 6, motherboard. The motherboard is a plastic circuit board that sits on the bottom of the computer, and mounted on the motherboard is the microprocessor and RAM. The microprocessor is a chip, such as the Intel chip, and it's the only part of the computer that can add 2 plus 2. The microprocessor is plugged into a socket on the motherboard. And RAM, which stands for Random Access Memory, is primary memory. It's working memory, and it holds the data that the computer is currently working on. And the bus is the little wires printed on the motherboard that connects together all the different components on the motherboard. The bus also connects to the slots, and circuit boards plug into the slots. We'll look at that later. Storage devices. You can save data to storage devices. Storage devices include hard disk, DVD drive, or USB drive. A controller card is a circuit board that can plug into the slot of a motherboard. A controller card is also known as an expansion card or an adapter card. It's also known as an I/O card. And examples of controller cards include a video card, or a network card, which of course we will be talking about a lot in this class, or a sound card. And these circuit boards are typically plugged into a slot in the motherboard, or they can be integrated into the motherboard, which we will look at later on in the class. Page 8, the BIOS. BIOS stands for the Basic Input-Output System, and it controls the boot process on the computer. To run the BIOS setup, we turn the computer on and we press either F2 or delete when the computer is booting up, or sometimes you have to press F10. And that will take you to the BIOS setup screen, which you will see on page 10. This is the BIOS setup screen. In the BIOS setup screen, you can specify the system time, you can specify the date, whether or not there is a floppy disk drive, and probably most importantly, the boot order. We can configure the boot order in the system BIOS. The BIOS setup allows us to configure the time and the date, whether or not a floppy disk is installed, and the boot order. Typically, your system tries to boot to the DVD first, and then if it can't boot to the DVD, it tries to boot to the hard disk. This BIOS information is stored on a chip called CMOS, which stands for complementary metal oxide semiconductor, and thank goodness you don't have to remember that. And the information on the CMOS is maintained by a battery. So if your computer is constantly losing its time and its date, or if the boot order is getting scrambled up, there's a good chance that the battery, which is on the motherboard, is going bad. Page 9 discusses booting a computer. And when you boot a computer, you turn it on, and the power goes to the BIOS chip. The BIOS chip runs the power on self-test, which we will discuss in greater detail later on in the course. And then most importantly, the operating system is pulled off of the hard disk and is loaded into RAM, and that's the definition of booting a computer. So the components of a PC include the system unit. In the system unit is the motherboard. Mounted on the motherboard is the microprocessor and RAM. Data can be stored to the hard disk. A network interface card is an example of a controller card, and the BIOS controls the boot process. Let's now turn to page 14, Fundamentals of Network Communication. But before we talk about network communication, let's discuss the advantages of not having a network. Let's take the example of you have a small company and 3 people work together and it's not networked. And we will find that the problem is there is difficulty in data sharing. So here's the example. We get 3 people working together, and they are going to work together to put together a proposal to build a garage for a customer, and they will submit a bid of how much this company would charge to build the garage. Bob will type in the cost of the concrete block. Jack will specify the cost of the framing, and Sue will specify the cost of electricity. So we start with Bob. Bob types up the proposal and adds the cost of the concrete block, saves it to a spreadsheet. He then saves that to a USB drive and gives the USB drive to Jack. Jack opens the file and he enters what his estimate is of the cost of the framing. And then he saves that. And then Bob gives the USB drive to Sue, and then Sue enters the cost as to what her estimate will be on the cost of roofing, $10,000 in this example. So now we have a proposal to give to the customer that says we can build a garage for this customer for $45,000. Now suppose Bob thinks about it and he says, I think I have to modify the cost of the concrete block. Bob wants to modify the proposal, but he's not too sure where it is. He gave it to Jack, but Jack gave it to Sue, and Sue may have given it to somebody else, so Bob really doesn't know where the original proposal is. So the statement of the problem is, it is difficult to share data when you are not networked. So the solution is, you get a local area network. You get a switch, which connects the PCs together, and you get a file server. And a file server is simply a computer with a big hard disk that everybody can save data to. So Bob types up the initial proposal and saves it to the hard disk. And then Jack and Sue can access this proposal, and now there's only one copy of the proposal, so there's no confusion as to where the latest copy of the proposal is. A file server allows many users to access the same file. And this is called collaboration. Collaboration is it's a big deal these days, and what it means is people working together on a project. And the point is, a local area network makes it easier for people to collaborate on projects. Whether or not they're saving the files on the hard disk on their local area network, or if they're collaborating on a project and saving the files up on a cloud server. And of course, we will discuss cloud computing later on in this class. Let's look at a second example of the disadvantage of not having a local area network, of not being networked, and the example would be the expense of having multiple printers. If everybody has a PC and everybody has his own individual printer, and you have a couple hundred employees, that's going to be really expensive, and you'll only be able to afford cheap printers for each employee. So what you do is you get a print server, and you connect a printer to the print server. And then the employees can print to the print server, which pushes the job to the printer. So now, instead of having a whole bunch of cheap printers, we have one really good printer, and everybody can share that one really good printer. So the advantages of having a local area network are resource sharing, file sharing, which allows for collaboration, or printer sharing, which allows many people to share one printer. And then if we look at communications, email communications and web communications allows private individuals to communicate and allows businesses to communicate. So the advantage of a network is resource sharing, such as file sharing and printer sharing, and communications, such as email and the World Wide Web. So fundamentals of network communication on page 14 lists the hardware components of a local area network: PC, network interface card, switch, cable, and server. So if we look at the components of a local area network, we start out with PCs. Every user gets his own personal computer. We put a network interface card in each PC, and we get a switch. Then we use a cable to connect the network interface card to the switch. Then we get a server, and then everybody can save their files up to the server hard disk so they can share those files with other users. That was networking hardware. Now let's look at networking software. A local area network is made up of clients and servers, and the client software would be the operating system that runs the client, meaning the workstation. The client is the workstation, not the user. The client's not a person. The client's a computer. And client software would include, for example, Windows 7 or Windows 8, the operating systems necessary for the client to operate. And then server software would include a network operating system such as Windows 2008 or Windows 2012 Server. Local area network software includes the client operating system and the server operating system. Now let's look at communication software. If we turn to page 19, page 19 discusses TCP/IP, which is a communication protocol which allows computers to communicate. If you go to a Windows 7 machine and you click on Start, and then click on Control Panel, then click on Network and Internet, and select Network and Sharing Center, and click on Change Adapter Settings, if I right-click on my network interface card and select Properties, I can see there is the TCP/IP protocol. If I click under Properties for the TCP/IP protocol, it shows the IP address of this computer. Telephones have telephone numbers, computers have IP addresses. So TCP/IP is a networking protocol. It is a piece of software that allows for communications between computers, and each computer has an IP address. To test TCP/IP, we can use the ipconfig and the ping command. The ipconfig simply shows you the IP address of the computer where you are currently at. So if I go to a computer and I want to know what the IP address is, I go to the command prompt and I type ipconfig, and it shows me this is the IP address of the computer where I'm currently standing. Now the ping command allows you to send a signal out to another computer, and if a signal comes back, then you know that that computer is up and running. If you can ping another computer and the signal comes back, you know the computer is up and running and all the cables between you and the computer are up and running. So if I want to determine if I can communicate with another computer, I ping the other computer based upon IP address. And if I get a reply from that other computer, I know the other computer is up and running and all the cables between me and the other computer are good. If I can't ping another computer, either that computer is not up and running or there's a cable break somewhere between me and the other computer. TCP, ipconfig, and ping will all be covered in greater detail in Chapter 5. Networking software, operating system software for the client, operating system software for the server, and communication software to allow the computers to communicate. Now let's turn to page 34 and discuss network models. We've already discussed what's meant by a server-based network. Now let's look at what is a peer-to-peer network. In a peer-to-peer network, you have workstations which are connected by a switch, but there is no server in a peer-to-peer network. So each user can access the hard disk on all other users' workstations. And if you have only 2 or 3 people and you work closely with those people and you trust those people, it's no problem with these 3 people accessing each other's hard disks because they work closely together. But when you work in a large company of hundreds or even thousands of people, you don't want just anybody accessing the hard disk of your computer. So a peer-to-peer network is only good for a very small network. Typically, most commercial organizations are going to have server-based local area networks, and they also call this a client-server network. In a server-based network, users can save data centrally to the hard disk on the server, so other users can also access those files and they can collaborate. They can work together on projects. Speaking of servers, let's discuss servers. Now, we've already discussed what a file server is. It's a computer we can all save data to. And we've already discussed what a print server is. But there are other servers as well, such as a database server, web server, application server, or domain controller. Please turn to page 36, domain controller. A domain controller, another word for a domain controller, is a logon server. Users log on to the domain controller. You can call it a logon server, you can call it a domain controller. It's also called an authentication server. An Active Directory is the database of usernames and passwords which is stored on the domain controller. Active Directory is a database of usernames and passwords, and we will cover Active Directory in greater detail in Chapter 9. What's the difference between a dedicated server and a multi-function server? If you have a small company, then one single server could act as a file server or a print server or a domain controller. But as the company grew, one server would not have enough processing power to act as a file server and a print server or a domain controller. So as the company grows, what we do is we get a separate dedicated server to be the file server, a separate dedicated server to be the print server, and a separate dedicated server to be a domain controller. Page 26 discusses what's a local area network and what's a wide area network. And I think everybody knows what a local area network is. This is an example of a very small single segment local area network. We have 6 clients, 1 switch, and 1 server. This would be an example of a single classroom here at CCBC. And then a larger local area network might be made up of multiple local area networks tied together. This is a diagram of CCBC Catonsville campus. We have multiple buildings. Each building has a switch in it, and all of the PCs in the building are connected to that switch. All of the buildings are connected together using a router, which we will discuss in greater detail later on in the course, and then the router connects everybody to the internet. So a local area network is a network which is confined to one geographic area. Now, it might be simply one classroom, or this is an example of the local area network in the CCBC Catonsville campus. One geographic area. Small local area network, large local area network. Now, a wide area network connects PCs or connects networks over long distances, such as all the way across the United States. And the internet is a perfect example of a wide area network. Local area network, wide area network. Now, a metropolitan area network is a network which is contained within a metropolitan area, such as Baltimore. Johns Hopkins University is a perfect example of a local area network, of a metropolitan area network, in that it connects all of the buildings together within the city of Baltimore. And then the storage area network we will cover later on in this class. Now let's turn to page 30 and discuss what is meant by a packet. Computers send packets to each other, and a packet is a signal which contains a message, and a packet is sent from one computer to the next. A packet is made up of data information and header information. Data is what you are sending, the data that you are sending, and the header includes the IP address of the destination computer. So let's look at communications between computers. Computers can only send positive and negative impulses to each other. A positive or negative impulse is represented as a 0 or a 1, and these are called bits. So if one computer can only send positive and negative impulses to another computer, how can it possibly send the number 7? In this example, we have 5 zeros and 3 ones, which represent the number 7. So the way one computer can send the number 7 to the other computer is it sends a combination of 8 bits together. 8 bits together is called 1 byte. And different combination of bits represent different values. So why does 5 negative impulses and 3 positive impulses, or you could say, why does 3 zeros and 3 ones equal 7? So this takes us to binary math. Can you please jump to page 239 to discuss binary math? So the question is, how is it that 5 negative impulses and 3 negative impulses equal the number 7? So here's how that works. One computer sends 8 bits to the other, and each bit represents absence or presence of a value. Each bit represents absence or presence of 1, or 2, 4, 8, 16, 34, 64, 128. So if we have 7 zeros and a 1, that's equal to 1. If we have 6 zeros and a 1 and a 0, that's equal to 2. If we have 6 zeros and 2 ones, that's equal to 3. How do you get that? Isn't 1 plus 1 equal 2? No, because the first one says we have a 1, and the second one says we have a 2. So 6 zeros and 2 ones is equal to 3. If we take a 1 followed by 6 zeros, that's equal to 128. A 1 followed by 7 zeros is 128. A 1 followed by 6 zeros and a 1 is equal to 129, because that's 128 plus 1. And if we have 7 ones, that's equal to 255, because that's 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128, which is equal to 255. Let's look at some other examples of binary math. If you have 6 zeros and 2 ones, that's equal to 3, because 1 and 2 is equal to 3. If you have 5 zeros and 3 ones, that's equal to 7, because you have a 1 and a 2 and a 4. That's equal to 7. If you have 4 ones, that's equal to 15, because you have a 1, a 2, a 4, and an 8. Add them up and you get 15. If you have 2 ones and 6 zeros, that's equal to 192, because you're adding 128 plus 64, which is equal to 192. 3 bits is equal to 224, because that's 128 plus 64 plus 32. And then 4 ones followed by 3 zeros is equal to 240, because that's equal to 128 plus 64 plus 32 plus 16. So notice, 4 zeros followed by 4 ones, this is 4 lower order bits, and 4 lower order bits equals 15, whereas 4 high order bits is equal to 240. So let's get back to the communications with computers. Computers send positive and negative impulses together. Different combinations equal different values. A packet is a message which is made up of data and header information. So if workstation 3 is going to send a signal to workstation 1, if workstation 3 is going to send the number 7 to workstation 1, it sends a packet. And the packet includes the number 7, and it includes the header specifies the address of the computer that it's going to. This is one way to look at a packet, but the more accurate way of looking at a packet is in binary. Because remember, computers send positive and negative impulses over the wire. So here's a better example. The header says it's going to workstation 1, and the packet says that it's sending the number 7. So this is a simplified packet, but that's how packets work, and that's how binary math works. Computers send packets to each other, and packets are made up of a series of zeros and ones, and the zeros and ones are represented in binary math. Kind of a tough subject, but we will focus on it more as we get into the class. So in summary, in this chapter we have talked about the components of a personal computer and the components of a local area network, the advantages of networking, peer-to-peer and server-based networks, types of servers, LANs and WANs, packets, binary math. And this concludes Chapter 1. Thank you very much. Have a nice day.